In lesson 2.2, we're talking about polynomial functions. I've got a few definitions at the top. A polynomial is an algebraic expression containing one or more terms. A degree of the polynomial is the largest exponent in the polynomial. The leading coefficient is the number in front of the biggest x value. The zeros are where it crosses the x-axis. And the multiplicity of the polynomial is the power on the factor. So we'll talk about that. What do polynomials look like? Well, a degree 1 polynomial is a function that has x to the first. That's why it is degree 1, because it has exponent of 1. And we know the graphs of those are linear. Degree 2 polynomial would have a square in it. And we've looked at those functions. Those would make parabolas. X cubed, we know, looks something like this. And then x to the fourth could look something like this. So notice the number of terms in the function is one less than the degree of the function. So here we've got x to the fourth. It turns 1, 2, 3 times. X cubed turns 1, 2 times. X squared turns once, and x to the first turns 0 times. It's just a straight line. So that means degree 5 would turn 4 times. So 1, 2, 3, 4, and would look something like that. So 1, 2, 3, 4. It doesn't have to turn 4 times, does not have to turn 3 times, but it could turn up to 4 times, could turn up to 3 times, and up to 2 times. How do we look at an equation and decide whether it's polynomial? Well, it has to contain one or more terms, so it has to have some sort of equation. The exponents have to be whole numbers, and the exponents have to be positive. And everything has to be real. We can't have any imaginary numbers as part of the function. So let's look at the following functions and determine whether they are polynomials. So here I've got 4 terms. A term is separated by a plus or a minus sign. So 4 terms. All the exponents are positive and whole numbers, and nothing is imaginary. So this is a polynomial, and it is degree 4. Because that is the largest exponent in the polynomial. Here, this looks weird. Now I can split this into 2 pieces to make it look better, if that helps. There are 2 terms here, and the exponent is 2, which is a whole number and it's positive, and nothing is imaginary, so this is a polynomial. And it's degree 2 because the largest exponent is a 2. This one doesn't have any negative exponents. However, we can rewrite this as x to the negative first. And so because it has a negative exponent, this is not a polynomial. This we can rewrite as x to the 1/2. So because it's not a whole number in the exponent, this is not a polynomial. In example 2, we are writing polynomials given their zeros. So this is kind of a backwards process. Given the zeros, so that's telling me that x equals -3, x equals 0, and x equals 5, if those are the zeros. And in order to get 0, they had to at one time equal 0. So we're going to add 3 to the other side so that it equals 0. This already equals 0. And I have to subtract 5 to the other side to get it to equal 0, which is why they are called zeros. Now, these are the factors of the polynomial. So we take these things that equal 0 and we multiply them together. And you can only do 2 at a time. Let's put these 2 together. So if I multiply these, I would have x plus 3 times x minus 5. And if you FOIL that, you get x squared minus 2x minus 15. So we FOIL those and we get that. And then we have the x still. So now we take that times x, and you distribute that, and you end up getting x cubed minus 2x squared minus 15x. So that is your polynomial, and you can check your answer. It says it should be degree 3, and I've got x cubed in my equation. For b, 3 zeros, so I've got x equals 4, x equals negative 4, and x equals 2. We want to set them equal to 0, so we're going to subtract 4, x minus 4 equals 0, add 4, x plus 4 equals 0, and subtract 2, x minus 2 equals 0. And then we take these factors and we multiply them. So this factor times this factor gives you x squared minus 16. And then we take this times the x minus 2. And so we would get x cubed negative 2x squared negative 16x and positive 32. And then we can combine like terms. So that would be x cubed minus 18x plus 32. In part C, I've got 4 zeros, so we're going to have 4 parentheses, and I think you're seeing the trend that if I have 4, it's x minus 4, negative 4 was plus, and then positive 2 was minus. So what we're going to have for these 4 zeros is x minus 1, x plus 1, and x minus 2, and x plus 2. And let's FOIL 2 at a time. So these two go together and make x squared minus 1, and I am foiling that. And then FOIL this, and you get x squared minus 4. And then we FOIL these. We multiply these together, so we're going to get x to the 4th minus 4x squared minus 1x squared plus 4. And you combine your x squareds together. So x to the 4th minus 5x squared plus 4. And you can check it's degree 4, which is what they said. Now multiplicity comes in. So if they say negative 2 multiplicity 2, what they're saying is negative 2, which will give you x plus 2, when you set it equal to 0. Multiplicity 2 means twice. That is a factor twice. 4 gives you x minus 4, and it says multiplicity 1, so we only have it once. So that's your multiplicity. Then you multiply everything. So we FOIL, and we get x squared plus 4x plus 4. Then we're going to multiply that by x minus 4. So I'm going to distribute my x, and I get x cubed, 4x squared, and 4x. Distribute your negative 4, and you get negative 4x squared, negative 16x, and negative 16. And then you combine like terms. So my 4x squareds are canceling. I've got x cubed. The x's go together and make negative 12x. And then we've got a negative 16. And this is degree 3, which is what I got. In example 3, they are factoring the polynomial for you, and they're asking you to identify the zeros, decide whether it's going to touch or cross the x-axis, and find the multiplicity of the factors. So if it touches the x-axis, it is going to be an even multiplicity. And if it crosses, it's going to be an odd multiplicity. So this would be even for touching and odd for crossing. So negative 3. When you set negative 3 equal to 0, that gives you no solution. When you set x minus 4 equal to 0, you get 4. When you set x plus 4 equal to 0, you get negative 4. And when you set that equal to 0, you get 1. So I've got 3 zeros. Each of them has degree 1. Each of these has x to the 1st, so they are multiplicity 1, 1, and 1, because they all have exponent of 1. And because the multiplicity is odd, then each of them is going to cross the x-axis. cross, cross, cross. So that's what they're asking for in A. For B, if I set x equal to 0, I get 0. And if I set x minus 3 equal to 0, I get 3. This x has an exponent of 1, so it has multiplicity 1. And this has an exponent of 2, so it has multiplicity 2 because of the square on the outside. And so this will cross the x-axis because it is odd multiplicity. And this will touch the x-axis because it has even multiplicity. On C, the negative 2 gives me no solution. If I try to solve the x squared plus 8, I'm going to get an imaginary answer because I'll subtract 8 and I'll try to take the square root of a negative and it won't work. So that's an imaginary answer, so no 0 there. So I just get x plus 1, or sorry, x equals positive 1. And so there is a degree of 1, so multiplicity 1, which means it's going to cross the x-axis. Over here, I've got 3x equals 0, which if I divide by 3, I get 0, which is multiplicity 1. There's a degree of 1. Here, I'm going to get x equals 2 with multiplicity 3 because of the exponent of 3. And so then this one is going to be cross because it's an odd multiplicity, and this is going to cross the x-axis because of the odd multiplicity. For E, we get negative 1, 3, and negative 5. The multiplicity here is 1, exponent 1, 2 because of the exponent of 2, and 3 because of the exponent of 3, which means this is going to cross the x-axis at negative 1. It's going to touch the x-axis at 3, and it's going to cross the x-axis at negative 5. For F, we have try to set that equal to 0. And so we're going to have negative 4, take the square root, and it's imaginary, so nothing. Here, if I set this one equal to 0, I would add 4 to the other side, take the square root, and whenever you add a square root to a problem, you put plus or minus. So there's 2 roots there. Let's split them. X equals 2, x equals negative 2. Now, together, they make multiplicity 2, but each of them just has multiplicity 1. Together, they make the squared, but separate, they're each multiplicity 1, which is crossing the x-axis.